Bas. I particularly like one of them. Now, these highlights were Bas's interpretations of yesterday's sessions and will be posted on boards out in the Columbia West gathering area just outside this hall, and they will also be on the website of the conference. And this is a good opportunity to tell you all that pictures of the conference are also being placed in the website, and if you want your own pictures to be uploaded, please come to the Secretariat, they'll help you do that. Let me just start now previewing the 3 sessions that we'll be seeing this morning. Or 4 exciting concurrent sessions on a range of topics, from applying ecosystem-based management in the face of changing oceans, developing future scenarios to help inform adaptation choices, understanding ocean acidification, and the impacts of ocean extreme events. Here's a quick description of each one of the sessions. Session 1 on ocean extremes and the impacts on marine ecosystems. The conveners Thomas Fröhlicher, Gabriel Regondo, and Emanuele Di Lorenzo. The session addresses ocean extreme events such as marine heat waves and the impacts these events can have on species, ecosystems, and the people who depend on them. The session will explore our understanding of changes in the frequency, duration, and intensity of ocean extreme events and how they unfold in time and space. We also have session 3, carbon uptake, ocean acidification and ecosystems, and human impacts. The conveners are Masahiko Fuji, Tsuneo Ono, Libby Jewett, Galen McKinley, and Ninji Zhao. By absorbing significant quantities of CO2, the ocean provides a critical climate regulation service. At the same time, carbon uptake is altering marine biochemistry, food webs, and ecosystem properties. In this session, we will explore a range of physical, biochemical, and sociological interactions that impact the ocean CO2 sink, rates of acidification, and ecosystem impacts. The third session is session 12, Scenarios and Models to Explore the Future of Marine Coupled Human Natural Systems Under Climate Change. The conveners are William Cheong, Lisa Crozier, Desiree Tomasi, and Wali Chen. Developing scenarios and models for the oceans that incorporate interactions between human and natural components are essential for understanding the dynamics of these coupled systems and informing climate mitigation and adaptation choices. This session will contribute to our understanding of the interactions between human and natural marine systems under climate change. And fourth, session 13, multiple stresses at multiple scales, ecosystem-based management in the face of changing ocean conditions. The conveners are Carol Robinson, Isaac Kaplan, Franklin Schwing, Philip Boyd, and Saskia Otto. The session investigates how interactions between climate-driven stresses such as warming, ice loss, ocean acidification and deoxygenation, and human driving stresses, such as fishing, coastal development, and pollution, impact marine ecosystem structure and functioning at a range of scales. But before we get to these sessions, it is my great pleasure to introduce the first keynote speaker of today, which is Vladimair Ryabinin of the IOC. Vladimair is the Executive Secretary of the Intergovernmental Oceanographic Commission, or IOC, of UNESCO, and is Assistant Director General of UNESCO. He will address the audience in a moment. Headquartered in Paris, the IOC is a UN body that promotes international cooperation and coordinates programs in marine research, services, observation systems, hazard mitigation, and capacity development to promote effective management of ocean and coastal areas. Dr. Ryabinin's background is in oceanography and climate, and he has extensive experience leading international and interdisciplinary research programs to better understand the interactions between climate and oceans. We are very pleased he could join us here today to share information on the upcoming decade of ocean science, designated by the United Nations to boost international science coordination and cooperation for better management of ocean and coastal resources. Please join me in welcoming Dr. Ryabinin.
Thanks very much. Thank you very much, Manuel. You know, you were very serious when you introduced me. I think I would like to keep the spirit of the cartoons. But you know, I will be speaking about something very serious. And this is actually the last slide of my talk. You can anticipate something here, I believe. Yes, that's exactly the last slide. So I'll go to the first slide. Try it at least. And then we will see all my talk. And I probably won't need to say anything. But anyway, so we are speaking about the decade of ocean science for sustainable development. You know, 2015 was really a crucial year in the international governance because once everyone agreed that we have to do something to this planet, and the agenda of 2030 was approved by all nations. So now we have a program for activities. But you know, this is not really a program. The problem is that's just the targets. Objectives and targets. We have to live happily, we have to have energy, water, we have to preserve climate, preserve the ocean, but how we do that? That is the big question. So in terms of, the good thing is that we have all reasons now to act. Governments are supposed to help officially and formally and also practically. So we have now Sustainable Development Goal 14 on the ocean, and if we implement the goal, that will be better fishing, sustainable fishing, and many other things like, you know, some science for ocean acidification and many other things. We have Sendai framework for disaster risk reduction, and this advocates for multi-hazard early warning systems. We have Paris Climate Agreement. I hope we are able to remain less than 2 degrees warm by the end of the century. We have Samoa pathway for small island developing states, focusing on their own problems. And we have, of course, a lot of issues related to biodiversity. But how we do this? That's the big question. So actually, my second slide was completely undermined by the wonderful cartoons that we saw. But the idea is indeed, it was captured really well. We have to be positive, we have to find solutions to these things, and engage science into action. So we have been doing this, but we can do more. And the key to this is engagement of people, of scientists, of governments, public at large, and also private sector. That is really important for this country that we are in now, for example. So we have to deal not only with climate change, but with all consequences of global change, environmental change that is happening. These are social, these are pollution-related things, overexploitation, and many other facets of this problem. And of course, we have to be highly visible and engaging everyone. This requires good communication. And we need really to think about the next generation. When we were discussing the decade, I think we always had in mind the idea of these young people that attended the first session. What is the world that we're going to give to them? So what is their future? What is the ocean that we're going to have? So that was actually the agenda of the big think tank, well, not so big, but quite good, actually, think tank that was organized by the Intergovernmental Oceanographic Commission of UNESCO at the beginning of 2016. At the time, we knew that there is already a sustainable development agenda. We knew about the Paris Climate Agreement. So how ocean science, supported by governments, can really make the difference? That was the big question. So we came up with an idea of a decade of ocean science for sustainable development. Ocean science is a shortcut to sustainable development in many ways. And then we had discussions how to develop this idea. We had massive support from United Nations organizations, many intergovernmental organizations, non-governmental organizations, individuals, companies. It was really overwhelming, that support. So we presented the idea to the Intergovernmental Oceanographic Commission of UNESCO Assembly. They approved this, and we came up with the proposal. You see the title page of this proposal on the screen. And we had tough negotiations in the United Nations the whole second half of the year 2017. Then on the 6th December, the 72nd session of United Nations Assembly basically proclaimed the decade of ocean science for sustainable development for 2021 to 2030. So what's the vision? So we need to develop scientific knowledge, build infrastructure, foster partnerships to trigger effective action towards sustainable and healthy ocean. Simple, But you know, it is really difficult to find a way of doing this meaningfully, engage everyone. So how are we going to achieve this? I think this is the most important slide of my presentation. So what we are going to do is basically to consolidate efforts and design several technological and scientific breakthroughs of ocean science and technology, and communicate the opportunities that will arise because of that to the rest of the world, so that it can be picked up by those people who do adaptation, mitigation, who do develop a blue economy. But we really need to develop some areas of science that require a breakthrough. I would like to give you a short list, and incomplete. This is still a moving target. We are working on this, and we would like you to work on this as well. So the first thing is a map of the ocean. When I think about the map, you probably may think about how you operate now in Washington, D.C. You have a GPS. Think about how primitive are maps of the ocean that we have. They're focusing on depths. We have 5% of the total area of the ocean depths covered with resolution of around 2 kilometers. Is it good enough for acting on the ocean? Not really. So we'd like to really develop science and technology of ocean mapping that will be creating a digital, geo-referenced atlas of the world, underwater surface. And this requires new science, new approaches. This, I think, will be a very important breakthrough. We are going to cover the whole topography, but beyond that, we are going to cover also ecosystems, activities, resources, and many other things. So the maps will be meaningful. This requires really design. So then, we have to really be serious about completing the global ocean observing system. Going to polar oceans, going deeper beyond 2,000 meters, to develop biological, biogeochemical, ecological parameters, and also bottom observations. We have now environmental DNA sequencing, but how we work with this, we just try to develop it kind of bottom up. It is not really picked up by many decision makers and those who can benefit from this. So if we organize a pool of interest for this system, I think it will make a big breakthrough in it. Then, what we manage in the ocean has to be done through management ecosystem management based on good science. So this is already a very developed area, but we need to consolidate a lot of activities. Management of fisheries, management of ecosystems, management of pollution, of activities, maritime spatial planning. This all requires consolidated approach. And the issues are, of course, and this has been already mentioned, multiple stresses. Again, we don't know a lot about deep ocean and bottom ocean ecosystems. This system has to be predictive. We actually, when we deal with ecosystems, we based our work on the parameters that look in the past. The future is going to be really different. So this also opens the possibility to be more proactive and more productive in informing adaptation activities. For example, if we act not only on corals, but on all elements of coral reef ecosystems, there's informed information about the environment in which they're going to live, then selective breeding of some elements of these ecosystems may be more productive and maybe faster. So there may be some breakthroughs in that area as well. Big data. There was a question, how big is the big data? I don't know. But the thing is that we need to have access to all the data so people can find what they want. This has to be the best data, robust data, and we are going to have a portal that will be opening this world of data to the world. This will be also something that we need to design carefully because there are so many players and so many authors, so many owners of data, but we would like to make the system so useful so it will be more beneficial for people and countries to inject data into the system rather than sit on it and don't give it to anyone. That is going to be a big change. Disaster risk reduction. We already have a system for tsunami warnings, but the system is very useful but very fragile. We have to make it a part of a bigger system that will be multi-hazard warning system, working with civil protection. So there must be another technological and also in terms of governance breakthrough in management of disasters and warnings about the disasters. So this is an important part to make our oceans safer for us. And so that was, for me at least, that these are exciting developments in science and technology. But the sad truth is that not many people in the world can really benefit from this. If you look at this map of the world, that is one of the pictures that we published in the Global Ocean Science Report of IOC. That report measured infrastructure and capacity of ocean science. You will see here a map of countries, an area which is deliberately distorted according to the number of publications. You will see there is no Africa. But Africa has an ocean science decade that they really need food. So how we develop the capacity of Africa, this is a really important way and a really important question. We have some ways of dealing with this. We have a clearinghouse mechanism for transfer of marine technology. We also really need to step up education and training in ocean sciences. There are some good seeds of growth in this area. But also what is important, this is also about the next generation. We have to make this world ocean literate. So it means when you ask a question about generation of oxygen, that will be in the textbook. We will normally see a tree and the picture of photosynthesis of a tree. And then I would say that probably 99% of school kids don't know that 50% of oxygen is coming from the ocean. So we really need to go to the school curriculum and make a chapter in it on ocean and the role of ocean in the life of people. So these are kind of where we are in the planning of the decade in terms of technological breakthroughs. So once again, this will be designed, energetically designed, and then implemented breakthroughs in which we invite you to contribute. Because your knowledge is really important for making this initiative very useful. But then, if we communicate the new environment, the new technological situation in the world, it will be possible to actually pick it up in many types of activities. So, like coastal zone management, like maritime special planning. At the moment, we have around 13% of total area of exclusive economic zones covered by governmentally approved and science-based maritime special plans. We hope that by the end of 2030, we have 50%, half of the area of all exclusive economic zones with maritime special plans, which means that activities there will be better organized, more coherent, and it will be huge input to sustainability of the ocean. Marine protected areas have to be also less political but more science-based. Fishery management needs also a lot of predictive science. So there are a lot of areas in which we can really capitalize on the advances in technology and science, and this is going to be the outcome of the decade. So by the end of 2030, we're going to live in a different world when ocean science is really informing decision-making, and decision-making is listening to ocean science. So how you contribute to this? We need you to participate. This is going to be an all-inclusive design during these 2 years that remain until the start of the decade in 2021, 2.5 years. So we need your input in the design of these breakthroughs. And I think the sessions that we have heard from Manuel today are going to contribute to this. So we really need to consolidate the knowledge and come up with good ideas how we can implement and the decade of ocean science. And we will take it to governments. So we hope very much that governments will keep listening, and there will be much stronger and more reliable support to all the areas that I outlined, and probably more areas because we are still collecting input. So very soon we're going to open a call for action, and there will be some ways of collecting collective wisdom of scientific community to this. So please be aware of this, wait for this, and very soon there will be a call on you. So we can, I think, all do it together, and by the end of 2030, I think I hope we'll be proud of what we have achieved. Thank you very much.